This lecture we will discuss about Taylor and Maclaurin series. So, so the contents are we will define what is power series, radius of convergence, Taylor series and Maclaurin series, and we will discuss few problems that discussed in Crazy textbook. That is your prescribed textbook. Okay. So I will define what is a power series. So, a power series in powers of z minus z naught is a series of the form sigma n equal to 0 to infinity a n z minus z naught all power n, which is equal to n equal to 0 then. Okay. കേൾക്കുന്നില്ലേ? ക്ലിയർ അല്ലേ? ഓക്കെ, റെക്കോർഡ് ചെയ്യുന്നു. A1 z minus z naught plus A2 z minus z naught all square plus etc. Where z is a complex variable, A0, A1, etc. are complex real constants. Okay, so and are called coefficients of this series, and z0 is a complex constant called the center of the series. So ഈ സെറ്റ് നോട്ടിനെ നമ്മൾ സെന്റർ എന്ന് പറയും. ഈ എ എൻ ആർ constants a0, a1, etc. Okay, so z minus z naught all power n, this series is called power series. Okay, if z naught is equal to 0, then our power series is of the form n equal to 0 to infinity a n z power n. This is equal to a0 plus a1z plus a2z square plus etc. Okay, now I will give you an example. Geometric series. You already know what is geometric series, right? Geometric series is sigma n equal to 0 to infinity z power n. This is equal to 1 plus z plus z square plus etc. Okay, and another example is if you take this power series. Okay, sigma n equal to 0 to infinity z power n divided by n factorial. So this is 1 plus z plus z square plus 2 factorial plus etc. Z cube by 3 factorial. So now the question is it valid everywhere? Okay, that means this is converges to a sum for any for z, for all z. Is it convergence for all z or a particular set? So for geometric series we know that 1 plus z square plus etc plus z power n plus etc, this is equal to 1 by 1 minus z, right? This you already know, geometric series sum. Okay, so this is valid only when mod z less than 1. So the thing is, so if you take this circle, unit circle, mod z equal to 1. So any point inside this, if you take any point inside this circle, this series sigma z power n equal to 0 to infinity converges. Okay, so if you take any point outside the circle, if I take 2, then is it converge? This sum is finite? No, because if z equal to 2, then we know that 1 plus 2 square plus etc, this goes to infinity. So this this series converges only when mod z strictly less than 1. Now for now our question is how to check this. That means if you have given a series, then we have to check for what values of z that series is convergent. Okay, so next, so for that we will discuss radius of convergence. So the definition is: consider the smallest circle with the center z0 that includes all points at which a given power series converges, and let r denotes its radius. And the circle mod z minus z not equal to r is called circle of convergence, and capital R is called radius of convergence. So we have to find if we have given a power series n equal to 0 to infinity a n z minus z naught all power n, then we have to find for all, what values of z this series converges to a finite limit. So this is if z naught is a point, we have to find a circle for which for which the series is convergent. So if you take any point here, say 2 2 plus I, then z 2 plus I minus z naught all power n must converge. That means if the radius of this circle is r, then z minus z naught is r. This circle is called radius of circle of convergence, and this r is called radius of convergence. Okay, so നമ്മുടെ ഇതെന്താ, ഒരു പവർ സീരീസ് തന്നു കഴിഞ്ഞാൽ നമുക്ക് ആ പവർ സീരീസ് ഒരു സെൻറ്റർ ഉണ്ടാവും, സെറ്റ് മൈനസ് സെറ്റ് നോട്ട്. ആ സെൻറ്റർ വരുന്ന ആ പോയിന്റ് വരുന്ന സെൻറ്റർ വരുന്ന ഒരു സർക്കിളിൻ്റെ we can find a circle for which if you take any value inside that circle, the power series gives a finite limit. ആ സർക്കിളിൻ്റെ റേഡിയസ് ആണ് റേഡിയസ് ഓഫ് കൺവേർജൻസ് എന്ന് പറയും. ഓക്കെ, so 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 how to find out radius of convergence? So I will give you hint. So if we take sigma n equal to z power n, this is 1 plus z square plus etc. Now okay, so we know that ratio test, you already studied ratio test, right? So what is ratio test? Okay, recall that ratio test is sigma an converges, or sigma some cn converges if limit mod cn plus 1 divided by cn less than 1. Okay, so this power series converges when limit n tends to infinity mod here cn is z power n. So z power n plus 1 divided by mod cn z power n is equal to, this is less than 1, which implies mod z less than 1. So this is the circle. Okay, this is the circle. That means z minus 0 less than 1. So this one is radius of convergence. Okay, so that is for a brief introduction for Taylor and Maclaurin series. So we discuss, നമ്മൾ എന്തൊക്കെ ഡിസ്കസ് ചെയ്തു? പവർ സീരീസ് എന്താണെന്ന് ഡിസ്കസ് ചെയ്തു, and we find some examples, and I told you that this series convergence in a circle, and ആ സർക്കിളിൻ്റെ റേഡിയസ് ആണ് റേഡിയസ് ഓഫ് കൺവേർജൻസ്. സോ നമുക്കറിയാം ഈ ഒരു ടൈലർ സീരീസ് അല്ലെങ്കിൽ ഈ ഒരു സീരീസ് എടുത്തു കഴിഞ്ഞാൽ ഇത് എല്ലാ പോയിന്റിലും കൺവേർജൻ്റ് അല്ല. ഫോർ എക്സാമ്പിൾ, ഇഫ് യു ടേക്ക് 2, this doesn't goes to 1 by 1 minus 2. Okay, so this happens only when mod z less than 1. Then mod z equal to 1 is the circle of convergence and 1 is radius of convergence. Okay. Now we will move to our topic, Taylor and Maclaurin series. So this is the introduction for your Taylor and Maclaurin series. Okay. So okay. Now we will define what is Taylor series. Now the thing is, if we have an analytic function, our question is, does there exist a series representation of f of z? Okay, so that is our question. Okay, that is our question. So for that we will define Taylor series. Okay, Taylor series of a function f of z, the complex analog of Taylor series is, that means we already know what is Taylor series. We studied in calculus. So that is the same thing. അത് തന്നെയാണ് ഇവിടെ എന്താണ് ഇതിൻ്റെ എക്സിന് പകരം z. That means it's a complex analog. Okay, f of z is equal to sigma n equal to, I am taking n equal to 0 to infinity a n z minus z naught all power n. So what is a n? Here a n is 1 by n factorial f nth derivative at z naught. So if you have given f of z, then we can find the Taylor series expansion of any function by using this formula. Okay, if z naught is equal to 0, then we say that Taylor series is called a Maclaurin series. A Maclaurin series is a Taylor series with center z naught is equal to 0. So clear ആണോ? Taylor series is f of z equal to sigma n equal to 0 to infinity a n z minus z naught all power n, where a n is this 1 by n factorial f nth derivative of z naught. Okay, so now we will discuss few examples. So first we will do first example is f of z is equal to, I'm taking 1 by f of z is equal to 1 minus z. Okay, screenshot. Okay, ഇപ്പം കാണുന്നില്ലേ? Okay, z f of z equal to 1 by 1 minus z. So uh, this is the function. Okay, we want to find out the Taylor series representation of this. So we know that Taylor series is sigma n equal f of z is equal to sigma n equal to 0 to infinity f nth derivative at so we want to find out Maclaurin series. Okay, z naught is equal to 0. Suppose for this is okay, this question f of z equal to 1 minus 1 by 1 minus z. We want to find out the Maclaurin series of f of z. Okay, so z naught is equal to 0. So this is 0 for Maclaurin series. Z naught is equal to 0 n factorial z power n, that is equal to f of 0 n equal to 0, then f of 0 f dash of 0 by 1 factorial z plus f double dash of 0 divided by 2 factorial, etc. Okay, now first we want to find out f of 0, f dash of 0, f double dash of 0, etc. So we have f of z is equal to okay, f of z is equal to 1 by 1 minus z. Then what is f of 0? If you replace z by 0, this is 1. F dash of z is 1. 1 by 1 minus z, derivative is minus 1 minus z all square into derivative of minus z minus 1. So 1 by z, 1 minus z all square, this equal to, this is again equal to 1. Okay, sorry, then f dash of 0 is equal to 1. Okay, now similarly f double dash of f double dash of z is equal to, okay, this is 1 by 1. So this is again derivative of 1 by 1 minus z all square is 2 by 1 minus z all cube. Then f double dash of 0 is 2. I'm taking it's a 2 factorial. 2 is equal to 2 factorial. So similarly, f triple dash of z is equal to derivative of this. That is equal to 2 into 3 divided by z minus all. So 3 factorial z minus z raised to. So f triple dash of 0 is equal to 3 factorial, etc. Okay. So I will write here. Okay. So now f of z is equal to 1 by 1 minus z is equal to f of 0 plus f dash of 0 divided by 1 factorial plus f double dash of 0 by 2 factorial plus etc. So we know, we already find what is f of 0. F of 0 is 1. So f of 0 is 1 1 plus f dash of 0 is again 1 1 by, sorry, z square plus f triple dash of 0 by 3 factorial z cube, etc. 1 by 1 factorial z plus f double dash of 0 is 2 factorial divided by 2 factorial z square plus f triple dash of 0 is 3 factorial divided by 3 factorial z cube, etc. So f of z equal to 1 by 1 minus z is equal to 1 plus z square plus z cube plus etc. And we already find the radius of convergence is 1. So this is valid when mod z less than 1. Okay. Now I will give you another question. Find Maclaurin series of e raised to z. So here given f of z is equal to e raised to z. Okay, solution. Now we know that Maclaurin series is f of z is equal to, we know z not equal to 0. F dash sigma n equal to 0 to infinity f nth derivative at 0 by n factorial z power n, which is equal to f of 0 plus f dash of 0 by 1 factorial z plus f double dash of 0 by 2 factorial z square plus etc. Okay. Now we have unknowns f of 0, f dash of 0, f double dash of 0, etc. So we will find that we have given f of z is e raised to z, then f of 0 is e raised to 0, 1, f dash of z is e raised to z, derivative of e raised to z is e raised to z, f dash of 0 is again 1, f double dash of z is e raised to z again, this f double dash of 0 is 1. So in general, f nth derivative of z is again e raised to z. So f nth derivative of 0 is again 1. Therefore, Maclaurin series of e raised to z is f, f of 0 is 1 plus f dash of 0 is again 1. So z by 1 factorial, 1 plus z by 1 factorial plus z square by 2 factorial plus etc. plus z power n by n factorial plus etc. Okay. So this is the Maclaurin series of. Now I will give you another. Find Maclaurin series of. So now if we want to find the radius of convergence, you just this is actually equal to sigma n equal to 0 to infinity z power n divided by n factorial. So if you want to find the radius of convergence, what you will do? Limit n tends to infinity mod z power n plus 1 divided by n plus 1 whole factorial divided by z power n by n factorial. This is less than 1. So which implies, so yeah, so you will get mod z divided by n plus 1 less than 1, limit n tends to infinity. So that means which implies limit n tends to infinity mod z less than n plus 1. So mod z less than limit n tends to infinity n plus 1. Okay. This implies mod z less than infinity. So that means this is valid e raised to z equal to sigma n equal to 0 to infinity z power n by n factorial. This is valid everywhere. Okay. For any z, this is valid. Okay. So we will discuss more problems in next class.